All right, watch and listen carefully here, guys. So in our first question here, we have a discus thrower spinning in a circle that has a radius of 1.6 meters. Okay, so they told us what R is. It's 1.6 meters. Okay, the maximum force that her arm can exert on the discus to hold it in the circle is 2,200 newtons. So that is our centripetal force. Okay, how long will it take for her to complete one spin? So we're looking for period because that's how long it takes for one spin. Okay, and the mass of the discus is 1.75 kilograms. Okay, so if we want to find T, there's two ways to go about this. Do this question in 2 steps or substitute in for V, okay, in the formula. So I'll show you in 2 steps first, and then we'll look at the substitution after. Okay, obviously period is not part of that formula. But if I know what V is, then I can find period with it and radius. Everybody follow me there? Okay, or I can substitute in, which I'll show you in a minute. So first let's solve for V. So I'm going to multiply, give them a mark for givens and a mark for that formula there. All right. So we're going to multiply both sides by R, and then we're going to divide both sides by M, and then we're going to square root in order to get V. All right, you can give them a mark for that as well. Okay, so we have then 1.6 meters times 2,200 newtons divided by 1.75, and we're going to square root that to get her speed. Okay, so all right, so she's spinning at 44.84 meters per second. Okay, so that's her speed. Now we want to find out how long does it take for her to make the single orbit. Okay, so obviously we want to keep all those decimals. I'm not going to write them all right now. Okay, so then we would say that V equals 2 pi r over t. So you can give them a mark for that. That'll be up to 4 marks. Okay, we need to manipulate that for t, so that'll be t equals 2 pi r over v. Okay, you can give them a mark for that, or if they plugged in the numbers, okay, so that'll be 2 times pi times 1.6 divided by 44.84, okay, and that'll give us our period. So 2 times pi times 1.6, okay, divided by our answer from the last one. All right, so it takes her 0.22 seconds in order to make one complete revolution. I think we only had 2 significant figures there yet. Okay, that would be their 6th and final mark. Okay, questions there? All right. Our next thing here, guys, is to look at the substitution of that. If I wanted to do this in 1 step instead of the 2 steps that I did here, okay, then it would look something like this. All right, I know that FC equals mv squared over r, okay, but I know that V equals 2 times pi times r over t. I'm going to substitute this formula in for V, but I have to square it before I do that. Okay, so it's going to look like this: m times 4 times pi squared, okay, times r squared over r times t squared. Okay, this r here will cancel that, and I'll be left with that formula. Then I would manipulate and solve for t. Okay, so I can substitute in, and that's something that we have to do, right, in order to solve some problems later on in the unit. All right, so that one's out of 6. All right, then we have a bank curve question here. So we know that theta is 18 degrees. Okay, we know the radius is 85 meters. Okay, it's covered in frictionless ice, so all that's keeping us in the corner is the bank of the curve. And we know that the speed coming in is 19 meters per second. All right, so I'm actually not going to use the 19 meters per second in any calculations. I'm only going to use it as a comparison. The question only wants to know whether this person will successfully negotiate the corner or whether they'll slide in or out. If they're sliding in, then is 19 too fast or too slow? Too slow. If they slide out, 19 is too fast. So what I need to do is solve for what's the proper speed for this bank corner. Okay, that's the trick to this one. All right, so my bank curve formula is tan of theta equals v squared over r times g. Okay, because you probably looked at this and went, what am I supposed to find? I have everything already. Okay, well at that point then it's a question that's kind of bigger than plug it into the formula. Okay, you have to think a little bit outside the box for one of these. All right, so I'm going to multiply both sides by r times g. So I'm going to have the tan of theta, times r times g square rooted will equal v. All right, so give them a mark for their givens, give them a mark for the formula, and a mark for the manipulation. Okay, when we plug in, that's going to be the tan of 18 degrees times the radius, which was 85 meters, times 9.81. Okay, so we're going to have square root of tan of 18 times 85 times 9.81. All right, so the speed for this corner is 16.4 meters per second. Do they slide in or out? Out. Okay, so you're going to get a mark for the 16 meters per second. Okay, that's your fourth mark. Out for your fifth mark. Okay, so the quiz is out of 11. Please give them a mark out of 11 at the top. Let them see it, and then in a nice neat pile right here